Okay, well, how's everybody today? I'm doing well. Good to see everybody again after a week. Everybody have a good spring break?
Yeah. I
Yeah?
picked out my prom dress.
You what?
I picked out my prom dress.
Nice. When is prom this year?
April 27th.
April 27th. Okay. So, I hope everybody had a good spring break, had the opportunity to kind of maybe take some time off. I'm sure we all had things to do, like work, and probably wanted to keep up with all your math, I imagine. That was probably a top priority. But it is good to see everybody. Glad you're back. What we're going to go ahead and do today is just review what we've been talking about prior to the break. I'm going to go ahead and pass back that sheet that the substitute gave you the other day. We're just going to work the problems together, kind of remember how to do them. And then tomorrow we'll continue with the notes, just kind of what's going to be happening this week and the next week. On Thursday, we're going to have a quiz over solving equations. So it's going to be, really similar to what we're doing right now. That's why I wanted to go ahead and take the day to kind of review. And also tomorrow, because it's been so long since we've seen it, I'm going to go ahead and give you some time in class, probably 20 minutes, I'm thinking, to work on an exit ticket that is very similar to the quiz you're taking on Thursday. So another opportunity to go ahead and refresh yourself, kind of review the material a couple of days before we take the quiz. And then next Thursday on the 28th, that's when you're going to have your second exam of the 6 weeks. Because we're already in the 4th week of the 5th 6 weeks. In fact, 2 weeks from Friday, 5th 6 weeks is over. We're in the last grading period. And for the seniors, I mean, we are that close to you guys walking across the stage. So there's not going to be a lot of time, between now and then. Oh, you won't fall. I've been, this will be my 16th one that I've gone to, and I can honestly tell you, in 15 graduations I've been to, I've not seen anybody trip once.
Yeah, but knowing my luck,
Get ready. There you go. Antonio's like, challenge accepted. Okay. All right, well, let me pass back these papers here. Lexi.
go out flat, come back.
Brandon. Daniel. Brett. Dolfo. There we go. Kirsten. Andrew. There you go. Israel's not here. Okay, we got Jay. Deborah. Leo. Okay, Angel's not here. Jalen. There you go. Andrea. There you go. Andrea. There we go. Marcus. And there we go. Now, that's all I see that was turned in, because I wasn't here that last Friday, of course, when the substitute passed these out. I do have extra copies if maybe you didn't turn it in, but you don't know where it went. So here's 2 right here. Who else needs a copy of the sheet? Genevieve? Anybody else? Okay. Yes, sir. Okay. If I can get these separated, there we go. Anybody else need a copy? Okay, so today actually ought to be pretty easy. In fact, all I'm wanting to do is just review these 10 questions. So as soon as we get them done, that's all I have for today. So it should be an easy first day back. One thing I did forget to mention next week, this will also be good news for you guys. While your test is on Thursday, remember you can always use your notes and everything. Next week is a short week. Why is that? Because you don't have to come to school on Monday. So you get a 3-day weekend. Okay, so that's something else to look forward to. Okay, so just in case you didn't know. Okay, well, we're doing that in the afternoon. We have to, every year, the state says, we have to be trained to do those things. But in the morning, we have what's called CFS. So I'm going to be getting together with all the other pre-calculus teachers and making sure that, we're on the same page. We're doing basically what we need to as far as the TEKS and the state goes. Okay. But basically, yeah, it's going to be a work day for us, and you guys get the day off. So, yay. Okay. All right. So let's go ahead and take a look at a couple of these. We'll go ahead and do these together, or at least some of them, and then hopefully we'll get some folks up here to go ahead and help me with some other ones. Like I said, as soon as we get these 10 done, this is all we got for today. And yes, ma'am. What'd you say? Oh, you want to do the first one?
I did, but I don't. So.
Oh, hey, I'm just going to go ahead and do it. Yeah, people are already volunteering to come on up. Sure. I won't turn down a volunteer. Okay, so we're trying to solve cosine of theta plus 1 equals 0.
Okay, so practice 1 to both sides. You're going to have cosine equals -1. Don't forget that theta.
Okay.
And you're going to go back, and since we know cosine is x,
Okay, and I have a
now we got to
chart
look
right here.
for where x is -1, which is, this is the only spot, right? Yeah.
That looks like the only spot. Yeah, all of these we're going to go ahead and solve on an interval, 1 rotation between 0 and 2 pi. And he's absolutely right. Cosine is the x value. So we're looking for the one ordered pair or ordered pairs that has an x that's -1. And that's the only location. That is exactly right. Okay, that is one answer that's going to make it true. Now remember, there's going to be an infinite number of answers. I'll go ahead and bring this up briefly. If I were to continue rotating, whether 1 or 2, and in the 2 directions, clockwise or counterclockwise, does anybody remember, because it's cosine, what would I add on the end if I wanted the infinite answers? Plus what? Okay. If it's cosine, I would add, remember 2 pi n? Where n represents the number of revolutions, so it could be 1 positive, 1 negative, and so forth. Okay. Now, what were the only 2 trig functions that I couldn't add 2 pi n if I wanted the general answer? Why is tangent and cotangent different? There you go. So tangent and cotangent would be just plus pi n. Very good. But we don't have to worry about that on these. I thought I'd just bring it up because it's been a while. But on all these, we're just solving between 0 and 2 pi. So 1 revolution. Okay. How do we do number 2? Well, let's take a look. Now, it says sine squared of theta equals 0, right? Now, I want to get this to 1 trig function equals some value or ratio. So how can I get sine from sine squared? Square root. Okay, so I'm going to take the square root of both sides. So the square root of sine squared, well, that's just sine. Okay, and the square root of 0 is 0. Now, normally, you would go ahead and put a plus or minus in front, but 0 can't be positive or negative. Okay, it's actually neither. So if cosine was the x value, what's sine? Sine is the y. So again, once you've got that trig function equal to whatever value or fraction you got from simplifying the problem, now we come back over here. Okay, where are all the locations where I have a y value that's 0? Okay, so right here we have a y value of 0, so that's an answer. And we also have a y value of 0 right here, so that is an answer. So this one actually had 2 answers or solutions I'm looking for in 1 revolution. Now remember, we always want to put our answers, in radians. So I'm going to go ahead and say 0 radians or pi radians. There you go. And of course, we could take out a calculator. I believe I have mine up. We could plug that in if you wanted to, just to see that it works. Any of these? Hey, Brandon. When we finish, we should be able to finish up. We're already 2 out of 10 done. Okay. All right. So now let's go through number 3 together. And then we'll see if anybody wants to come on up and do the next one after that, because it's very similar. So here it is. 2 cosine of theta minus the square root of 3 equals 0. So let me write this out. 2 cosine theta minus the square root of 3 is equal to 0. Okay, well, what am I going to do here? Okay, so let's add the square root of 3. Yeah, any extra terms, let's go ahead and get rid of those first. That's absolutely right. So opposites are going to cancel. So 2 cosine of theta equals the square root of 3. Divide by 2. Remember, we want to get that trig function by itself. Divide by 2, divide by 2. So it looks like cosine of theta is equal to square root of 3 over 2. Now, if you're looking at these trig equations that are cosine or sine, they're the easiest because cosine is x, sine is y. But even if it's any other trig function, if it were tangent, well, then you would just look for the ordered pair, the y divided by x. Okay, just use their ratios to help you figure that out. Well, let's see there. Positive square root of 3 over 2. So I'm going to come back over here. Where are all the locations where an ordered pair has an x that is a square root of 3 over 2?
Pi over 6.
There we go. There's 3 pi over 2. Square root of 3 over 2 right there, pi over 6. And what was the other one? There you go. There's another positive square root of 3 over 2. So 11 pi over 6. Now, wait a minute. Like, I'm looking at one right here. There's a square root of 3 over 2. But it's negative. There you go. So signs are going to be really important. So here, the only two answers, I'm looking for pi over 6 or 11 pi over 6. Pi over 6, 11 pi over 6. Okay, so it has been a while, but is it starting to come back to you guys? Okay. Anybody have any questions on what we're doing? No? Okay. Let's take a look at number 4. So 2 sine of x plus the square root of 3 equals 0. Who wants to come on up and help me with this one? Well, Brandon, you already came up and did one. Appreciate it. Oh, the other Brandon? Okay. Brandon R. Sure. There you go, sir. Okay, so we're going to subtract the extra. That's absolutely right. That's fine. Okay. Okay.
So now it's going to be negative square root of 3 over 2.
So are we wanting to look for the x value again?
It's signs, we're going to want to look for the y.
We're looking for the y. Okay. So let's click that top icon right there. All right, so let me go ahead and erase these very quickly. All right, so he got sine of x equals the negative square root of 3 over 2. Where do I have y values that match that?
4 pi over 3.
Okay, so I heard 4 pi over 3. There's a negative square root of 3 over 2. And 5 pi over 3. There's another y value, negative square root of 3 over 2. That's it. That's all there is to it. Okay, easy, right? 4 pi over 3 and 5 pi over 3. Good. So I'll write this out to the side. 4 pi over 3, 5 pi over 3. Good. Well, now we're to number 5.
Alright, so, can I just tell you that?
Sure.
Okay. So you can change it to like 1 over cosine.
Okay, now I would actually wait until the end for that. Because let's go ahead and get secant by itself. So you're absolutely right. Let's subtract 2. Okay, so this is going to give me that secant of x is equal to negative 2. Now remember, what's secant's ratio? Okay, it is 1 over cosine if you're looking at the identity. But remember, cosine is always x over r, right? So secant is always r over x. So what you could do is work backwards, use that ratio. But I like Brandon's idea. If it's something other than the original 3, if it's secant, cosecant, or even cotangent, I would probably go ahead and use his idea. Put in the reciprocal, cosine of x, but then what's negative 2 as a reciprocal?
Wait, 1 over 2. Yeah.
Negative 1/2. See, all I did was take the reciprocal. So see, now I don't have to go through and hunt for a ratio r over x to give me negative 2. I can just immediately say, okay, I'm looking for an x value that's a negative 1/2. Is everybody okay with that? Could it have been done the other way? Yeah. I probably would have drawn a triangle, but on this one, these equations, I think we've been doing better just looking at the unit circle. So where is an x value negative 1/2? Okay, so I heard 2 pi over 3. There's a negative 1/2 right there. And then 4 pi over 3. There's another negative 1/2 right there. That's exactly right. Okay. So 2 pi over 3 and 4 pi over 3. Whoop, that's not what I needed. Okay. So for number 5, 2 pi over 3 and 4 pi over 3. And you can always test it to make sure that your answer is correct. You can plug it back in and see if it does give you a true statement. Like, for example, my calculator is in degrees, so let's look at 2 pi over 3. What's 2 pi over 3 in degrees? 120. So I should be able to plug in 2 plus secant of 120, 2 plus the secant of 120 degrees, and it should give me 0, okay, if I'm correct. So let's come on over here to your calculator. So 2 plus, the trig function is right between equals and 7. So we had secant. And see, the reason I'm using degrees is because that's the mode my calculator is in. Okay, so I'm going to plug in 120. And when I push enter, there we go. See, it gives me 0. So it confirms me that's an answer. Okay. What was 4 pi over 3 as a degree measure? Okay, there you go. So I should be able to plug in the same thing, 240, and it still give me 0 as well. Okay, so if you're ever not sure, you can also check it on the calculator. Okay, good. Right there, we're already halfway through. Perfect, perfect. Number 6. Now this one looks interesting. Tangent of theta times cosecant of theta plus 2 equals 0.
So, could you do sine over cosine and like change tangent to sine over cosine and then have the
Now you can. You can actually manipulate the equation if you want to, but there's a property that we can use that will immediately just allow me to go to my answer. Does anybody remember what it is I'm referring to?
it would be the cosine one, right? The cosine because cosecant plus 2.
Remember, I'm multiplying 2 items, and what's the result? Well, what does it equal? Oh, it equals what? It equals 0, right? So you guys remember the 0 product property? You don't remember that? Okay, that's okay. That's why we're doing this. Okay. Remember, if you're multiplying 2 items and the result is 0, then one or the other, one of the terms has to equal 0. Now this one, you remember how one of the last things we had right before spring break was we were pulling out a common factor, a GCF? Well, that one's already been done for you. See, we already pulled tangent out of this binomial. So I'm going to take each one of these. First off, tangent of theta equals 0. And then I'm going to do the other one, cosecant, if I get it right, cosecant of theta plus 2 is equal to 0. And see, now I'm going to solve them individually. Okay. Now, the first one is going to be a lot easier, but here's where you have to think about the ratio. I'm not looking for 0 exactly. I'm looking for the ordered pair. When I take the y divided by its x will give me 0. Okay, so I'm going to come back over here to my unit circle. What ordered pairs can I take the y value, divide by the x value, and get 0? Okay, so 0, okay, because 0 divided by 1 is 0. Okay, and Brandon says pi, because 0 divided by -1 is 0 as well. Now, couldn't I do it with pi over 2? That'd be undefined. Y divided by 0. Remember, you're doing what the trig function tells you to. You're taking the y and putting it over the x. So for that one, I've got 0 and I've got pi. Okay, so for this answer, theta equals 0 and pi. Now I'm going to turn my attention to the other one. And I heard somebody tell me what to do before I solved the other one. Subtract 2. So cosecant of theta is equal to a -2. Now let's do the same trick that we just did on number 5. So instead of trying to figure out which one the r divided by y would give me -2, well, why don't we just take the reciprocal? Why don't we just change it back to one of the original 3? What's the reciprocal of cosecant? Sine. So I'm going to go ahead and say sine of theta, and now what's the reciprocal of -2? There you go. See how we don't have to deal with that new trig functions ratio? Just the reciprocal gives me a nice, easy value to look for. Okay. All right. So now I'm looking for every location where there's a y value that's a -1/2. But I think we actually already did this one. Okay. Or we get something really close. We did have a -1/2 a moment ago, right? Okay, so here's 7 pi over 6. There's a -1/2. And what else? 11 pi over 6. There we go. So this equation actually had how many answers? It had 4. Okay, 0, pi, 7 pi over 6. Let me get back over here. So 0, pi, 7 pi over 6, and 11 pi over 6. I know, right? Okay. So how do you think we're going to go ahead and solve this next one, number 7? I would do the same thing. See, cosine was a common factor, a GCF, but it's already been pulled out for you. You're multiplying 2 items, so I'm going to set each one of them individually equal to 0. So either cosine of x is equal to 0, or tangent of x minus the square root of 3 is equal to 0. Okay. Now, what's cosine again? What value? It's the x. Okay, so Rhett, help me out, sir. I'm looking at my unit circle. I need every location where an x value is 0. How many are there? There are 2. What are the locations?
The pi over 2 and pi over 2.
Okay, there's a 0 right there at pi over 2. And where's it?
The 3 pi over 2.
There's another x that's a 0 at 3 pi over 2. So I got 2 answers out of that first one. Pi over 2, 3 pi over 2. Now for this one, we have to do a little bit of algebra. Okay, so what would tangent of x equal? Yeah, so you just go ahead and add the square root of 3 to both sides. So tangent of x is equal to the square root of 3. Now, here's where you have to be careful, though. I'm not looking for a value that is specifically the square root of 3. I'm looking for the ordered pair, whose when I take the y value divided by the x will give me the square root of 3. Okay. So let's see. I'm coming back over here. Now, we could probably go ahead and narrow this down. Like, for example, look at these ordered pairs in quadrant 2. We can eliminate all of those. Why? There you go. Because we have a positive y and we have a negative x. So a positive divided by negative would give me a negative. So we can eliminate all those. For the same reason, we can eliminate these in quadrant 4. Again, the negative divided by the positive would still give me a negative. But is quadrant 3 still open? That would be a possibility, because what's a negative divided by a negative? That's a positive. So we're looking for answers most likely in quadrants 1 and 3. Is everybody okay how I narrowed that down? Okay. What do you think?
Square root of 3 over 2 times 2 over 1.
Okay, so you're thinking this one right here?
Yeah.
Now let's check it. Let's take this y value and divide it by this x value. So square root of 3 over 2 divided by 1/2. Well, what do we do when we divide by a fraction? And what's the operation? Multiply it. So this will be the square root of 3 over 2 times 2 over 1. So that would give me the square root of 3. That's very good. Now what I'm going to do, I'm just going to follow this line right across. It'll lead me straight to the other answer. Okay. And let's see. Even if I had these as negative, what's a negative divided by a negative? Positive. So that one will be providing me 2 answers as well. Pi over 3 and 4 pi over 3. Okay. Good. That was number 7. Okay, how we doing? Okay. How many people have been getting all these right so far?
Not all.
Not all of them, just a few mistakes here and there. Okay, all right, good, 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 good. Okay, well, let's take a look at number 8. Now, what do you notice about number 8? Like, what was already done on 6 and 7?
They already pulled out.
There was already a common factor pulled out for you. So on number 8, what's the common factor? Cotangent. Okay, so we're going to solve it exactly how we did number 6 and 7. So this binomial right here, cotangent squared of x plus cotangent of x, if I were to divide out a cotangent, okay, now that's going to leave me a plus here is equal to 0. Brandon's actually right. Okay, cotangent of x plus 1. Just think, what's cotangent times cotangent? There's your cotangent squared. Cotangent times 1, there's your cotangent. Okay. So see, this problem right here is exactly now like the previous ones. What's that property I can use? Starts with a z? The zero product property. Is everybody okay with how I did that? Okay. So I'm going to take the first part, cotangent, and I'm going to set it equal to 0. Then I'm going to take the second part, cotangent of x, plus 1, and I'm going to set it equal to 0. And then we just solve these. Okay. All right. So cotangent, what's his ratio? Okay, it's what? X over y. Very good. So x over y. So I'm looking for the ordered pair whose location I can take the x divided by the y and get 0. There we go. And right away, Brandon again says pi over 2 and 3 pi over 2. 0 divided by 1 is 0. 0 divided by negative 1 would also be 0. That's absolutely right. Is there anything wrong with 0 and pi? That would be undefined for cotangent. There you go. Okay. So here, we'd have pi over 2, 3 pi over 2. Now, over here, cotangent of x plus 1 equals 0. Well, what would I do for this one? Okay. So let's subtract the 1 over. Cotangent of x is equal to negative 1. So I'm looking for every location where the x divided by the y value would give me a negative 1. Or you could take the reciprocal. I mean, you could say tangent of x equals negative 1 because the reciprocal of negative 1 would still be negative 1. It's completely up to you. Well, let's see. Where do I have some locations where an x divided by its y would give me a negative 1? Second and fourth one. Okay. Oh, so you're talking about the quadrants. So the second and the fourth ones? Okay, so where in the second and fourth quadrants would you say the answers are? 3 pi over 4? Okay, see, they're both the same, so anything divided by itself is 1, right? But a negative and a positive, that would give me negative 1, as would the 7 pi over 4, x divided by the y. Well, wait a minute. What's wrong with, say, pi over 4? That would give me a positive 1. Remember, we're looking for a negative 1. So 3 pi over 4 and 7 pi over 4. There we go. That is number 8. Okay, questions. Okay, so I tried to design this where it was kind of building on itself, and you could use previous examples to help you. Brandon?
Is there 4 answers in this one?
This one has 4 answers, yes. Pi over 2, 3 pi over 2, 3 pi over 4, and 7 pi over 4. Exactly right. Any of those, if I plugged into the original equation, should simplify and give me 0. Okay, well, let's try number 9. So we've done quite a few of these together. Cosecant squared of theta plus 2 cosecant of theta equals 0. Well, I would probably do what we did on the previous problem. Pull out a GCF. Who wants to come help me out with this one? We're almost done. We're down to our last 2. So many hands going up. Remember, as soon as we finish, we're done. Oh, Brandon, you already did one, though. I want to get some people who haven't been up here. Oh. So who wants to help Brandon out? He's got to go to the bathroom. Who wants to come on up and solve the problem? Anybody? Anybody? Okay. After a full week, nobody wants to come up to the board? Come on. And you know everybody's going to help you out. I'm going to be able to help you out. So, Christian? Or what? All right, Lexi says she'll come on up. There we go. Okay. So this one she's having some problems with. Okay. So we're doing number 9. So how would we solve this? I pull out a GCF. That's exactly right. In fact, what is the GCF? Cosecant. Okay, so let's pull out a cosecant. So we'll put cosecant of theta. And now in parentheses, what would I have left if I divided out cosecant from those 2 terms? Brandon's absolutely right. Cosecant theta plus 2. And it equals what? Equals 0. There we go. Now again, what property can I use? The 0 product property. So we're going to take each of those 2, one at a time, set them equal to 0. Okay. So how would I write that out? Cosecant of theta equals 0. Okay. And then cosecant theta plus 2 is equal to 0. Okay. So now, which one would you like to look at first? The first one? Okay. So cosecant of theta is equal to 0. Now, what would the reciprocal of 0 be, though? Would it be 0? Because think about it. Right now, you've got 0 over 1, and the reciprocal would be to put 1 over 0. So it'd be undefined. So that one, you don't think we'd be able to get an answer on that one? I would agree. Okay. Is that? Oh, I thought that was VD. I'm sorry. Okay. Now there you go. So I would subtract 2. So cosecant of theta would equal what? Would equal -2. And I would go ahead and do what we did previously. If you have a cosecant or a secant equation, I would take the what? I would take the reciprocal. So what's the reciprocal of cosecant? So what should sine of theta equal? There you go. Take the reciprocal of both parts. So sine of theta equals -1/2. And there we go. We just took the reciprocal. We just flipped it. So -2 over 1 just becomes -1 over 2. And now, that one I actually think we solved, right? Sine of theta equals -1/2. But where are all my locations where a y value is a -1/2? We have 7 pi over 6. That's it. So there's only 2 answers for this one. 7 pi over 6 and 11 pi over 6. Perfect. And then we're doing our last one. Okay. And I'll tell you what, Brandon, if you want to come on up and solve this one very quickly, then I can let you run, because I don't want you to sit there and squirm too much. Yeah, there you go. Okay, so he has tangent squared of x minus 3 is equal to 0.
So we're going to add 3. Tangent squared theta is equal to 3 equals square root of both. You have tangent equal to square root of 3.
There's just one thing you're forgetting. No? He took the square root, so what has to go in front of the square root of 3? Plus and minus. There we go.
So we're going to have
So how many answers am I going to end up with? 4, 1 from each quadrant. And in fact, let me do this real fast. Erase the previous one.
fancy.
So we actually saw this before. Like, what ordered pair could I take the y and divide by x? He's already showing me. There we go. Square root of 3 over 2 divided by 1/2.
Right? Those are all.
So it looks like his 4 answers, he's telling me pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Would you guys agree? I would agree. That is it. That is exactly right. Thank you, sir. Why don't you go ahead and grab that pass and head on real quick. Okay, now he did that pretty quickly. Any questions? Anyone not sure where he got an answer from? Where did he get the 2 from? You talking about when we solved the original equation?
Yeah, like after that, like where did he net?
Oh, like, okay, so we have plus or minus the square root of 3. How do we know those 4 locations? Okay. So what he did, he just took each of these and took the y divided by the x. So like, for example, this is an answer because if I take this y value and put it over this x value, square root of 3 over 2 divided by the 1/2. Remember, that's the same as the square root of 2 times 2 over 1. And see, there's the square root of 3. But the thing we're looking for here is a positive or negative square root of 3. So any ordered pair that has these values, doesn't matter what sign, those are where I'm going to find my solutions to the equation. Okay, so it has been about a week and a half, but is it starting to come back for everybody? Good? Okay, so tomorrow we'll go ahead and start looking at those quadratics where you can't factor out a GCF. We'll actually have to use that my father method, and then we'll just go from there and see how far we get. Okay, questions? Good. Let's go ahead and start.